Hey, hello and welcome back to Algebra 1 Honors Lesson 5-3. Today we're going to be talking about monomial factors of polynomials. Now the book presents this topic in a different way than I'd like to present it. I'm going to show you the way the book shows you to do it, and then I'm going to show you the way that when you get into high school, 9th, 10th grade, you're going to be required to do it this way. All right, so let's look at an example. Okay? Let's look at 5m plus 35 divided by 5. Okay? 5m plus 35. And both of these guys are going to be divided by 5. Okay, so there's two different ways you can do it. But because this is factors of polynomials, we're going to do the greatest common factor method. First, let's look at this method, which is equally correct. What I'm going to do is I'm going to take my 5 and put it under each one of the numerators. 5m divided by 5 plus 35 divided by 5. And we can easily see that 5 over 5 is a 1. So we're going to put a 1 here. And 5 divided by 35, if you want, we could break this down to this. 5 times 7, okay, over 5, and this would be a 1, 2, and we would have a 7 left. Okay, so our answer would turn out to be m plus 7. Okay, now, a way that makes more sense to me, this is a good way, but when you get into polynomials, it gets a little harder to do this. And here's another way. This is using the greatest common factor to solve the problem. All right, so first thing you do is you look and you say, what could be the greatest common factor of 5 and 35? Okay, if you didn't know, let's just pretend we didn't know. I do know what it is, but if I didn't know, I could use prime factorization to figure it out. I would put a 5 here, that's one number, and a 35 here. Okay. Well, 5 goes into 5 one time, and I stop here, so it's going to be 5 times 1. And this guy is going to be what? 5, and then it comes down to be 7 and 1. We stop. So 5 will equal 5, and 35 will equal 5 times 7. Now, whenever you're looking for the greatest common factor, you have to have two numbers that are common to both the top 5 and 35. What two numbers are common? Well, that's easy to see. It's our 5s. So the greatest common factor of this term will be 5. So I take my 5 out, and I put it like this, 5 times, and then I'm going to have m plus 7 here, and now I'm going to divide it by 5. Can anybody see anything a little different here? Yes, we can see 5 over 5 is going to be what? It's going to be 1. So when this turns into 1 here, my answer is going to be left with m plus 7. And this is the way I prefer to do it, and it's easier, it gets easier when your binomial turns into a polynomial. Okay, now, let's look at a couple more of their problems, and we can basically do them the same way. And let's see, here's one where it's 26, I guess it's 26 UV. We'll do it both ways, and then we're going to depart from the book way, and we'll just concentrate on the greatest common factor way. All right, and as the numbers get larger, this prime factorization way of finding your greatest common factor works tremendously. It works very well. All right, let's look at this one. We've got 26 UV, 26 U and a V, minus 39V, and they're dividing it by 13V. All right, if we do it the book method, we would do it like this. We would put 26 UV divided by 13V minus 39V over 13V. Okay, let's analyze this for a minute. 13 can go into 26 two times. okay? So we're going to put a 2 here, but we've got a v over v. So what's a v over v? That happens to be a 1, okay? So we're going to have 13, we're going to end up with 2, and then u. And over in this case, 13 goes to 39 how many times? 3 times. And guess what happens to the v over v? It changes into 1. So our answer here would be 2u minus 3. Okay, now if we do it the other way, we would say to ourselves, what is out of 26 and 39? We don't know this, so we're going to come over here, 26 and 39, and let's get the prime factorization. Well, I could take a 2 out of here, 2, and I end up with 13. And you stop when you get to 1. Over here, I can take a 3 out of this one, and I end up with a 13. Okay, so I'm going to rewrite this, and I'm going to say the prime factorization of 26 equals 2 times 13. The prime factorization of 39 equals 3 times 13. Okay, let's look at this. Let's let our eyeballs look at this. We're looking for the greatest common factor, a factor that is common to both 26 and 39. That's right, it is 13, because there's 13 here, 13 here. So our greatest common factor will be 13. So I'm going to put 13 on the outside here, and I'm going to kind of rebuild my problem. And I say to myself, 13 times what number will give me 26? Well, that number is 2. Okay, and I have what times u will give me a u? Just the plain old u. 1 times u is u. 1 times v is v. So if I multiply this times this, I'm going to get this answer as 26uv. I do the same thing over here. 13 times what will give me negative 39? It will be 3. 3 will be 39. And I have 1 here. 1 times what will give me a v? V. And all of this, you see? I only did the numbers for the greatest common factor, but what I didn't tell you, or I didn't represent, is that we should have went one step further. We have our numbers, but we should have came over here and did our letters, okay? So over here I have a u and a v, and over here I have a v. So what's the common factor? I know they're letters, they're not numbers, but what's the common factor that's common to both 26 and 39? Bingo, it's a v. So instead of writing 39, I made a little boo-boo, but it's okay, we caught it. And we're going to take the v's away, and we're going to put our v right here where it belongs. Now we're going to redress this and say 13v times what gives me 26uv, and it's 2u. 2u. And 13v times negative 3 gives me a negative 39. Okay, now what am I dividing by here? I'm dividing by the 13v. Anything look familiar? When you multiply it only happens when you multiply. Can you cancel out the numerator and denominator? And this is, you're multiplying 13v times this, divided by 13v, so it easily turns into a 1. And what we're left with is the same answer we had before, 2u minus 3. Okay, and those guys are the same. All right, let's try a little more difficult one, and then, all right, let's do example 7. 8a squared bc squared. And we're just gonna do it the greatest common factor way. All right, let's try this. And I think once you get used to it, you're going to find the preferred method too, because as the numbers get bigger and as you get more and more letters, it gets more difficult to figure out what is your common factor. But if you use this simple technique, it will not be that difficult. All right, let's look at this one. It says 8a squared bc squared. 8a squared bc squared. You see, our letters are becoming more. We're getting a little more in depth. Minus 12ab squared. 12ab squared. And is it c? C squared. Okay, now, they say here, factor this, the greatest factor. Okay. We're going to look at two numbers. We're going to look at them all. We're going to look at the 8 and the 12. So 8 is going to be here, and the 12. Okay, I do know the factors of 8 already, which is 2 times 2 times 2. And the factors of 12 is 2 times 2 times 3. Now, in addition to that, let's look at, what do we have? We have two A's here. So I'm going to write A times A, and we have a B and a C and a C. Down below here we have an A, we have a B and a B, and we have two C's. Now, we're going to be getting the numerical value and also the variable value, and we're going to convert it into our greatest common factor. All right, what would our numerical value for our greatest common factor? Well, I have 3 2's here and 2 2's. So I only have two sets of two 2's that are common to both. This one and this one. Even though I have a 2 here, I don't have it here. So I'm going to take 2 times 2. It's going to be 4. On the outside, I'm going to have 4. And you can easily see that 4 goes into 8 and 4 will go into 12. Now, the next step is we have to figure out our letters. Well, I have 2A here and 1A here, but I have to have them in common. So I only have one set of A's in common. That's okay. I got a common, so I put A here. Now let's look at our B's. I only have one set of B in common. And the last one, oh, we're lucky. I have this set and this set, so this is actually going to be C to the second power. Okay, now that I've taken out my greatest common factor, all I have to do now is rebuild this term here. What do I have to do to get an 8? I have to multiply by 2. I have an A and I need an A squared. I have to multiply by A. I have a B and I already have a B. What do I have to do? That's a good one. I don't have to do anything. I've already got it. I've already got a C squared and a C squared. I don't have to do anything. Multiplied by 1, but that's almost doing nothing. So 4 goes into 12. What do I have to do to get a 12 here? I have to multiply 4 by 3. I have an A here and A here, so I don't have to take any action. I have a B, and I need a B squared. So I have to multiply the B by another B to get a B squared. I have a C squared and a C squared. I don't have to do anything. So the answer to this problem is 4ABC squared times 2A minus 3B. Okay? This, my friends, is the greatest common factor that we factored out, and this is the rest of it. Okay, and that's basically all there is to it. But please don't forget, when you do these problems, you have to always include, okay, your letters too. You get your greatest common factor of your numbers, and then you check out your letters. And if you follow this way, 99 and 9/10%, you'll always get these type of problems right.